When people think of planetary rings, Saturn almost always comes to mind, with its glorious icy arcs visible even through backyard telescopes. But did you know that Jupiter has rings too? That's right. This giant gas planet also sports a ring system, though much more subtle than Saturn's. Welcome to Infinity Beyond, where today we reveal the hidden beauty and surprising science behind Jupiter's ring system. Discovered in 1979 by the Voyager 1 spacecraft, Jupiter's rings are faint and dusty, invisible to the naked eye and even most telescopes. It wasn't until spacecraft got close that we realized the planet's massive gravity supports a thin system of particles encircling it. The rings are composed mostly of microscopic dust grains, rather than large icy chunks like those in Saturn's rings. These particles are primarily created by impact events on Jupiter's small inner moons, such as Amalthea, Thebe, and Metis. When meteoroids strike these moons, debris is ejected into space and captured by Jupiter's gravity, forming the rings. Jupiter's ring system consists of four main components: halo ring, a thick torus-shaped region closest to the planet, extending from the top of the atmosphere outward; main ring, the brightest and densest part, mostly composed of dust from the inner moons; Amalthea Gossamer ring, a diffuse ring fed by the moon; Amalthea Thebe Gossamer ring, even more extended and faint, linked to the moon Thebe. Despite being barely visible, these rings tell us a great deal about moon-meteoroid interactions, the behavior of dust in magnetic environments, and how minor impacts shape planetary systems. Unlike Saturn's icy rings, Jupiter's are dark and absorb most light. Observations in the infrared and ultraviolet spectrum have helped scientists map their extent and composition. Even the Hubble Space Telescope and JunoCam aboard the Juno spacecraft have captured them, silhouetted against the planet in scattered sunlight. The rings are also dynamically active. As Jupiter rotates, its powerful magnetosphere interacts with charged dust particles in the rings. These magnetic interactions can push or pull particles into new orbits, slowly altering the ring system over time. Interestingly, the lifetime of the dust in the rings is short on cosmic scales, only a few thousand years, meaning the system must be constantly replenished by impacts on nearby moons. If these impacts stopped, the rings would gradually disappear. This gives us a dynamic snapshot of a living planetary system in motion. Jupiter's rings also give scientists insight into how ring systems might form around other planets, and even exoplanets. Understanding how faint, dusty rings behave in strong gravitational and magnetic fields could help interpret future discoveries around alien worlds. Moreover, these rings help us understand the evolutionary timeline of the Jovian system. The fact that Jupiter's rings are not as massive or icy as Saturn's may be due to a different collisional history, or the absence of icy moons close enough to contribute material. As Juno continues its mission, it provides valuable new angles and data to study the rings, their interaction with Jupiter's atmosphere, and the tiny moons that sustain them. These faint arcs of dust, though often overlooked, are part of what makes Jupiter not just a planet, but a miniature solar system with its own delicate architecture. Next on Infinity Beyond, we'll zoom back out to the big picture, asking a bold question: what would happen if Jupiter disappeared from the solar system entirely? Could Earth survive without it?